So, binomials. You guys remember what binomials are, right? Those are these things. Okay? We're going to talk about binomial expansions. What is x plus y to the 0 power, guys? 1. Anything to the 0 power equals 1. And what is x plus y to the first power? It would just be x plus y, because anything to the first power is what it originally was. Now, x plus y to the second, we'd have to do a little math for that, so you might not know it right off the top of your head. But how would you do it if you wanted to go about doing it? X plus y times x plus y, and that's a FOIL problem. Like you have to use the FOIL method or the box method, right? And then for this one down here, x plus y to the third, you'd have to probably do the box method twice, and down here maybe even 3 times. And that gets to be a lot of work. But something interesting comes out of the works here whenever we set them up and look at them. Some patterns kind of start to pop out at us. For the sake of time, I'm just going to go ahead and share the patterns with you here. The easiest one to see is the exponents, and it's really clear when you look at the last one. Notice that it starts with x to the 4th, right? That's what it was raised to in the beginning anyway, right? But it's x to the 4th, and it goes to x to the 3rd, then x squared, then x to the 1st, and then there's no x at all. So it's going down 1 each time, right? Do you guys see the same pattern with the y there? The y is doing the same thing, but it's going backwards. It's y to the 4th at the very end there, and then it's y to the 3rd, y squared, y, and then no y. And that's true for all of them. They're all like that. Now here's the harder pattern to notice, and I'll give you a chance to think about it for a second, because actually someone in my last class saw it. The red ones, the red numbers in the front, called coefficients, right? What's the pattern there? I mean, I could tell you the easy one to notice. It's symmetrical, okay? So if you were to like draw a line down the middle here, notice that it's 1 and 1 on both sides. On this one, it's 1 and 1 on both sides with a 2 in the middle. This one is 1 and 3 on the left and 3 and 1 on the right. Same thing on the bottom. So they're symmetrical on the left and right side. But that's not really going to help me get the next row, is it? How can I get the next row? You see it, Mark? It is Pascal's triangle. Did we talk about Pascal's triangle in here already? But you've seen it before? Well, nobody's quite shouting out the exact answer yet. Mark seems to know it already. Here's how it works, though. To get the next row, you add the 2 numbers directly above it. 1 plus 1 makes 2, right? 1 plus 2 makes 3. And then 1 and 3 make 4. 3 and 3 make 6. 3 and 1 make 4. Okay, so if I wanted to do the next row, we could do that now. Let's go ahead and move on to the next slide. I'm going to actually have you guys make that triangle on your notes now. Go ahead and get down the title. I'll do the first few rows for you. And then I'll let you guys do the next few rows all the way up to the 7th row, okay? So here's what we should have then for up to the 7th row. I'm going to show you how we use these to do some problems now. Go ahead and write down example 1, please. Okay, so we have 2x minus, what was it? 5 to the 5th power. And here we go. Well, thinking back to the patterns we observed, you remember that the first term always started with the highest power and it worked its way down, right? So let's look at the first term here. We have 2x, and the power we're raising it to is 5. And the next one will be 1 less than that, so it'll be 2x to the 4th, followed by 2x to the 3rd, and then squared, and then to the 1st power. And then the last one's to the 0 power, but we're not even going to write that because anything to the 0 power is what? 1. All right. that's what will happen with the first term. Now remember, our pattern with the exponents with the second term was similar, but it did something different. What did it do? Huh? Yes, kind of. It started on the other side, right? In other words, it went backwards. So what is my second term? Be careful with that one. It's negative 5. So negative 5, and you're still going to start with the power of 5, but we're working backwards this time. So it's going to be negative 5 to the 4th, negative 5 to the 3rd, so on and so forth. And then negative 5 to the 0 is just going to be 1, so I'm just going to put a 1 there now. But that's just the exponents. We also notice that pattern with the coefficients, right? What do we use to get the coefficients? The triangle, Pascal's triangle. So notice my exponent is 5, right? So what I'm going to do then is I'm going to go back to Pascal's triangle there. We're going to find row 5. Do you guys see it? It's the one with the 1, 5, 10, 10, 5, 1. Those are my coefficients that I'm going to use. So here we go. So I'll put C for coefficients. 1 was the first one. 5, 10, 10, 5, 1. So if I just put all these together now by multiplying them straight down, then we'll get the whole polynomial. It's up to you. Some people might just do all this right now in their head. I kind of like to rework it a little bit and do each piece alone, like 2x to the 5th. If you do that separately right now, you would get 32x to the 5th power, because 2 to the 5th is 32. And of course, you have your x to the 5th. What's 2x to the 4th going to be? 16x to the 4th, right? And the next one will be 8x to the 3rd. Good. Next one will be 4x squared. And the last one is just going to be 2x. And then we're done with that row. I'm going to do the next row now. Now negative 5 to the 1st power will be what? Just negative 5. Anything to the 1st power is itself. Negative 5 to the 2nd power. Positive 25. A negative times a negative is positive. And as a matter of fact, you're going to find that anyone with an even exponent, it's going to be positive. Anything with an odd exponent is going to be negative. So it's going to be switching back and forth. Negative 5 to the 3rd power. Negative 5 times negative 5 times negative 5 is negative 125. Yeah. This one will be 625. It'll be a positive. And then the last one I'm going to need a little help with. I don't know that off the top of my head. It's going to be a negative, though. Know that. Say it again. 3125. Okay. So each row has been simplified. Now to get the actual polynomial out of this, we just have to multiply down. So 32x to the 5th times 1 gives me the first term, which is 32x to the 5th. Let's do this one. 16x to the 4th times negative 5 times 5. I'll work it out really quick on my calculator here. Getting negative 400x to the 4th. The next one. 8 times 25 times 10 is 2000x to the 3rd. Next one. It's negative 5000x squared. Next one. $62.50 x. And the last one's negative 3125. Now, even though it might have seemed like a long time, I guarantee it would have taken a lot longer, and there probably would have been a lot more mistakes if you tried to FOIL those together, like multiply 2x minus 5 by itself 5 times. It would get pretty messy pretty quick. So that, believe it or not, is a lot shorter.